This slide lists the properties of normal urine. So the pH of normal urine can range from 4.5 to 8, but the average is around 6, which is slightly acidic, but not overly acidic, but it's very, very slightly acidic. The specific gravity, which is the density of urine compared to the density of pure water, is just a little bit above pure water. It's specific gravity is, it's about the same, really. 1.003 to 1.03 isn't a whole lot different than 1. And then it lists the osmolarity or concentration between 855 and 1,335 milliosmoles per liter. That may not mean anything to you unless you compare it to it's what it means is the number of solute particles per liter. So fresh water is about 5. So there's a lot more solutes in urine, as you would probably expect. Body fluids tends to be about 300. So and that makes sense because you're wanting to get rid of certain solutes, by urinating. The water content is very high, 93 to 97%, even higher than blood plasma. Plasma is, I think, 90%. Okay, the volume, about 700 to 2,000 milliliters per day, and that's going to be, adjusted for things like dehydration, etc. Color is clear yellow, and odor varies with composition. Bacterial content, it should be sterile, none. For normal urine, there should be no bacteria in it. All right, checkpoint question 7. A decrease in blood pressure would have what effect on the GFR? Remember, that is glomerular filtration rate. So blood pressure is directly related to GFR. So therefore, if your blood pressure decreases, it would decrease GFR. What effect would low circulating levels of ADH, antidiuretic hormone, have on urine production? Low levels of ADH. Okay, so what does ADH do? ADH helps you to retain fluids. It helps you to reabsorb water back into your blood. Okay, so if you don't have much of it, then you're going to tend to not retain fluids, so it would have the opposite effect. So you're going to, it's going to be a larger volume of dilute urine. Low levels of ADH would be consistent with larger volume of dilute urine. Now, we're going to talk about regulation of kidney function. Autoregulation is also known as local regulation. So, for example, in response to reduced blood flow and decreased GFR, the afferent arteriole that serves each nephron, the afferent arteriole and glomerular capillaries are going to be dilated, and the efferent is constricted. So afferent and capillaries are dilated to increase blood flow into the filtration unit, the renal corpuscle, and then the efferent is constricted to constrict blood flow coming out. So that's a combination of things that's going to raise the actual blood pressure in the renal corpuscle and increase the GFR. Afferent arteriole and glomerulus are dilated, efferent arteriole constricted. This increases glomerular blood pressure, and the GFR increases back to normal. If the blood pressure rises, the exact opposite occurs. Afferent arterioles and capillaries constrict, efferent dilates. So those are things that can happen just directly at the level of the nephrons that will raise and lower GFR. Okay? In response to increased blood pressure and flow, which is going to increase GFR, that will reduce the afferent arteriolar diameter, reduce the flow into the glomerulus, and decrease GFR back to normal. Hormonal control of kidney function involves some hormones that we have talked about already in various body systems, but we're going to go over them again. particularly we've discussed these in the cardiovascular system, but now we'll be able to understand really even better the overlap between cardiovascular and urinary systems. So the major hormones are angiotensin II, which of course that's involved in the renin-angiotensin response. So renin goes along with that. So angiotensin II, ADH, aldosterone, and ANP, or atrial natriuretic peptide. For the renin-angiotensin aldosterone system, what happens is when you have a drop in blood pressure or blood volume, because they are correlated with each other. So drop in blood pressure or blood volume activates this renin-angiotensin aldosterone system. So the combined effects are peripheral vasoconstriction, so constriction of peripheral blood vessels. That increases blood pressure in the renal arteries. It increases blood pressure, period, but it would increase blood pressure in the renal arteries. Constriction of efferent arterioles, which increases GFR. We already talked about that. Adrenal secretion, so the adrenal glands secrete aldosterone, epinephrine, and norepinephrine, and that will increase sodium reabsorption. And what have we learned? Sodium, water follows salt. Sodium is part of salt, so that's also going to increase water reabsorption. Water will follow that sodium back into the bloodstream. So this is aldosterone, epinephrine, and norepinephrine is going to increase sodium reabsorption and therefore water reabsorption back into the blood. And the release of ADH from the posterior pituitary gland, all of that together is going to increase glomerular pressure and GFR. And that is hormonal control. All right, so this illustration here, diagram, shows you what happens to restore normal GFR. It's, of course, negative feedback is involved here. So it shows you what happens if blood flow is decreased to the kidneys. Okay, so that's the stimulus, is blood flow is decreased to the kidneys. And you can follow this through, but it shows you the role of the juxtaglomerular complex, which I talked to you about a little bit, where okay, remember that this is your nephron loop. It's part of the DCT that comes up in between the afferent arteriole and the efferent arteriole, and you have the macula densa cells and the juxtaglomerular complex. So these are like sensory receptors. And when they detect this decreased flow to the kidneys, the cells of the juxtaglomerular complex release renin into the bloodstream, and renin triggers the angiotensin II release, and then angiotensin II triggers aldosterone secretion, and then renin also starts a neural response. The angiotensin II starts a response by the nervous system. So a lot of things work together. So aldosterone increases sodium retention. Your nervous system causes you to be thirsty, so you're going to drink more. Your nervous system stimulates increased ADH production and release by the posterior pituitary gland, which increases fluid retention. Increased sympathetic nervous system activity. That would be the hormones epinephrine and norepinephrine. They're going to cause constriction of systemic veins, increased cardiac output. All of that is going to stimulate vasoconstriction. Peripheral vasoconstriction just means blood vessel constriction in general, not just to the kidney, okay? And all of that leads to two things: increased blood volume and increased blood pressure, which is going to restore homeostasis, restore normal GFR. So again, this shows you what happens to lead to the renin, angiotensin aldosterone system being stimulated, and then the effect of it. So it's going to be low blood flow to the kidneys, activates the juxtaglomerular complex, which the beginning step is to release the juxtaglomerular cells release renin into the bloodstream. That triggers angiotensin II and aldosterone, as well as the nervous system, the sympathetic nervous system, which releases, it doesn't say here, but it said in our notes, releases epinephrine and norepinephrine. Okay, so the main effect is to increase blood pressure back to normal. ADH has two key effects: increasing water permeability of the DCT and collecting ducts, which increases water reabsorption, leads to water retention. So the two effects of ADH are to cause you to retain water and to stimulate thirst so that you drink even more water. So you retain water and you drink more water. So that's going to raise your blood volume, and raising blood volume raises blood pressure. The effects of aldosterone are going to be reabsorption of sodium along the DCT and collecting duct, reabsorption of sodium, and of course, water follows salt. So it raises the sodium blood level, and water is going to come follow the sodium by osmosis. And secretion, remember the difference in reabsorption and secretion. Reabsorption of sodium means the sodium leaves the tubular fluid, which is like pre-urine, and enters the blood. Secretion means that potassium was in the blood, so now it's being secreted into the tubular fluid. So that reduces potassium blood levels so that more is lost in the urine. Okay. Atrial natriuretic peptide, ANP, is released by the atrium of the heart. That's why it's called atrial. And it affects sodium because the Latin name for sodium, the reason it's given the symbol Na is that it's natrium. So natriuretic means that it acts on sodium. Okay, it's released by the heart and it acts on sodium. The key effect is to lower blood volume and blood pressure. So this one is different from all the other hormones that we have discussed so far related to urine or kidney output. Instead of raising blood volume and blood pressure, it has the opposite effect, lowers blood volume and blood pressure when it's too high. It does this by inactivating the renin, angiotensin, aldosterone system, inhibits the secretion of renin, aldosterone, and ADH, and decreases the rate of sodium reabsorption in the DCT. I don't know what that comma is doing there. But anyway, it decreases the rate of sodium reabsorption in the DCT. And for sympathetic activation in the kidneys, sympathetic activation always decreases GFR. Remember what the sympathetic nervous system does overall is it prepares you for the fight or flight response. You don't want your kidneys and your urinary system to be active and functioning when you are trying to run for your life or fight for your life, or in a situation like, even if it's something small like you're singing a song in church or about to give a speech, you're really nervous. You don't want to accidentally, have an accident, pee yourself, So sympathetic activation in general just decreases GFR. It decreases the urinary system's function in general. It just does that. Okay. So anyway, kidney stones. All right. So we're moving on. New topic. Kidney stones are also called calculi. They are solid substances made of calcium deposits, magnesium salts, or crystals of uric acid. They can form within the kidney, the ureters, or the urinary bladder. It results in a painful is not even the word from what I understand. I've never had one, but I've taught a lot of students over the years. I mean, I'm in my, I'm close to retirement. I think like I'm 27th year or something like that. So I'm not that I'm going to retire in 30 years, but I could, So anyway, bottom line is I've taught a lot of students, and when we get to this chapter, I've always been curious about this, the pain from kidney stones. because I've heard men in my own family say that it's worse than childbirth, and how can they even know? So, and I personally had scheduled C-sections with my children, so I never had labor. So I have done my own little research over the years. I've talked to many women who had kidney stones and labor, even women who had labor without, natural, what they call a natural childbirth. So they didn't have any pain meds or epidural or anything. I've never had a woman tell me that childbirth is worse than kidney stones. It's always been the opposite. Kidney stones are extremely painful, and that painful condition is called nephrolithiasis. So just from my own personal research, I haven't actually written down or documented, but since I've never had anybody tell me anything but this, I can tell you I feel pretty certain that kidney stones are more painful than labor. And I may be the only person interested to know that, but I've always wondered about it, Anyway, kidney stones obstruct the flow of urine, and they may reduce or prevent filtration. So they could even not only the pain of kidney stones, but they can also affect kidney function. But definitely the pain is not something anybody could live with. So they have to be passed, the stones have to be passed. All right, now we're looking at the organs for conduction and storing urine, and we're out of time. So I'm going to start with this slide on the next recording.